Hey everyone, we're going to cover section 9.3. That's the top of page 67. That begins 9.3. And all we're going to do today is jump from two sample proportions, which we just covered, and go to two sample means. And so just like we did for the one sample stuff, we're going to do the same thing for the means as we did for the proportions. We're going to focus on technology. The formulas and the tables get a little more difficult to deal with, so we're going to either use StatCrunch or your calculator to do these problems. And the only thing that really changes then is your symbol in your null and alternative. We're going to look at the difference between two sample means, and so we're trying to estimate mu1 minus mu2. So our null hypothesis is that the two means are equal, and then an alternative can just have less than, greater than, or not equal to in it. And so here we have the formula for the test statistic, and then you get a p-value. And to use your calculator function, you go to 4:2 sample t-test, and I'll show you that in a second. We're really not going to cover using the table. I want you guys to use technology, so either StatCrunch or your calculator. And then you can get a confidence interval for the difference as well. And here's the formula for that, and here's the calculator function for that. Okay, so the first problem, there's no calculation necessary, and this is going to be a typical problem where we're not going to focus so much on the calculation, but more so on the interpretation. And so we have a confidence interval for the difference between two population means. We're comparing males and females. That's what the subscripts are, M and F, and we're looking at heights. And it says the confidence interval for the difference in the means, mu M minus mu F, is between 11.6 and 17.4. We want to interpret that. And so we have to notice what sign it is. Is it positive or negative? Because we're taking males minus females, we would expect it to be positive because males are taller than females, and so their height's going to be greater. So if you subtract males minus females, you would expect positive numbers. And so this confidence interval here is for the difference in height between males and females. And when I interpret my confidence interval, I should state which group is higher or lower. So males are taller, and they're taller by between 11.6 and 17.4 centimeters. So we can be 95% confident that, and I need to include the word average in there since I'm comparing the means, that men are between 11.6 centimeters and 17.36 centimeters taller than women. Okay, so some important things here. I used the word average. I stated specifically which group was taller, and then also by how much. Okay, and then the next page covers how to compute this as well, and also hypothesis testing. And so the first example is from the book, and they're just comparing having a red background and a blue background and recording test results. So seeing if they're different results if the background is red or blue. And we're going to use a 0.05 significance level. And so I want to calculate a test statistic and p-value, so we're going to rely on the computer to do that. First thing I'm going to do is state the null and alternative. Now I want to remember to use mu, not p. And I always subscript it with what makes sense. So B and R in this case makes sense. And then we're just seeing if they're different, so I'll have not equal to in the alternative. Okay, so at this point, I'm going to go to the computer. Well, I'll do it on the calculator first. So here's the calculator. And I want to do a two sample mean test. So I'm going to go to Stat, and I'm going to go to test, and then I'm going to go down to, or I'm sorry, I missed it, number 4, 2-sample t-test. And so I'm going to hit enter. And then I just have summary statistics, so I leave that there. And then I just want to enter the data. So there's the box for the data. I have 15.89. Whoa. Sorry. 15.89. And then my standard deviation is 5.9. And then 35. And then I have 12.31. And then 5.48. And then 36. And let's see, then I have to tell it the direction of the alternative. We have not equal to, so I select not equal to, and I hit enter. And it's not doing anything. And then we're just going to leave it on no for that. And calculate. Okay, so my test statistic is 2.64, or round that up to 2.65, and the p-value is 0.01. All right, and so let's just go ahead and do it on StatCrunch. StatCrunch, I want to just go to stat, t-statistic, 2-sample with summary. And it comes up with this box. And so I just enter the correct information. So I have 15.89, 5.9, and 35, 12.31, 5.48, and 36. So it couldn't be too much easier in StatCrunch either. I'm going to hit next. I can do a confidence interval if I wanted to, or a hypothesis test. For the 2-sample, this will always be 0, and then I just pick the correct alternative. Okay, so here are my results, 2.65 and a p-value of 0.01. So let's go ahead and go back to the notes and write up our results. Let's see, what was it? So the test statistic was equal to 2.65. And the p-value is equal to 0.01. Okay, so conclusion, you guys should know how to do this by now. We were looking to see if there was a difference between average test scores for the red background and the blue background. Our p-value was 0.01. And we're using a significance level of 0.05, so we can reject H0 and conclude. So since we're rejecting H0, we're going to conclude that the alternative, that we have support for the alternative, which is that the average scores are different for the blue and black, red and blue backgrounds. Okay, and then we'll just finish the confidence interval up as well. Because we found a small p-value, we would expect that our confidence interval would not include 0. So I can go back to StatCrunch, And I've already entered the data, so if I want to do a confidence interval, I can just go to Edit and just switch this down to confidence interval and calculate. Okay, so my confidence interval goes from 0.885 up to 6.275. So let's go ahead and record that before I forget. And so we have 0.885 to 6.2, forgot already, 6.27. And so we interpret it as the difference between the blue and the red scores. And since I entered the red scores first when I entered it on the computer, that means that those scores must have been higher, and actually the sample mean is higher for that. And so I can say we can be 95% confident that using the red background will result in test scores that are between 0.885 and 6.27 points higher than the blue background. And I forgot to use the word average, so I'll just throw that in at the end, on average. Okay, so I'm comparing the blue and red background, and so I want to state which one has the higher scores. And because the red came first and the confidence interval was positive, that means that the red must have had significantly higher scores. Okay, just lastly on the calculator, I would go to Stat, Test for the confidence interval, and then it's number 10 for the confidence interval for the difference. So 2 sample t interval. And I've already entered my data. And so I just hit calculate. And there's the confidence interval for the difference. It's a little bit slightly different than using StatCrunch, just by a little tiny bit, but we'll just use what StatCrunch gave us. Okay, and your instructor in class will go over this in more depth. This was just kind of an introduction.